in the due course of our engagements. Yes, Gabriel, you can share with us. Gabriela, share with us.
I think we should learn more about fractions.
More about fractions, wow. Esther?
Yes, Teacher Lynnder.
Which topic do you think I should give attention? Fractions as well, so that we can complete it?
Yes.
Wow. I'm so amazed by Gabriela because we're looking at fractions before. I thought she was going to tell us something different and possibly figure out when to do it. But I'm glad she has also told us we look at fractions, and I'm looking forward to doing that. So Esther, basically, Gabriela, basically in fractions, what is giving you that kind of hard time?
Dividing fractions.
Adding? Dividing fractions.
Yes.
Okay. So now we are going to look at that under operation of fractions because it is our new topic we are going to start with. Actually, subtopic because we had opened up fractions with Esther before. And since you've specified and that's under operation, we are going to look at it. So expect something good out of our engagement. And I hope you'll be proud. Gabriela, is it fine?
Yes.
Okay. So Esther, did you go through the work in the unit that is there at the site?
Not all of it. Some of it.
Okay.
Yeah.
But had you looked at? Did you look at part of that part of operation? Because I wanted you to go through it before I started.
I didn't.
Okay. All right. So today, I want us to look, we are going to look at additional fractions. And if time allows, we shall go beyond that.
Great.
Yeah. In additional fractions, remember we have, there are two kinds. We have the one of similar denominators, and this one is just revision because we've been seeing this work. And our interest will be on different denominators, although we shall look at how it looks like, that one of different similar denominators, and also see how it can easily be done.
Great.
Yes. Gabriela, do you have an idea about additional fractions with different denominators? With similar denominators, sorry. Okay, you have an idea about it. Okay.
Yes.
How about the one of different denominators?
I also have an idea.
Wow, that's great. So I would like to give you this opportunity to give us your idea about similar and different denominators as well. You start with similar, you can tell us, give us a hint.
When we are adding fractions with similar denominators, we only, when we are adding fractions with denominators, we add the numerators and the denominator remains.
I've not got the last bit of the words so well. So I beg you repeat them one more time.
We are adding fractions with similar denominators. We add numerators and the denominator makes the same.
Okay, thank you so much. That is with the similar denominators. Okay, I want us, so let us share this. I'm going to be changing my gadget and using another one so that I can share my screen and we see Esther so that we can see what she's trying to mean, okay?
Yes.
Okay. Let me just just a moment. I'll be connecting because I've been using another one and I want to change, but we can still share as well. When you're working with subtraction and addition of similar denominators, one thing you should know, similar denominators, that means the parts are the same.
Emma, no?
That means that the parts are the same. So what we do, we maintain the denominators. We maintain the denominators and we only look at the numerators. So the addition takes place only with the numerators. And the subtraction also takes place with only the numerators. So this operation, actually addition and subtraction of fractions, for it so much concentrates on the numerators. So it takes place with the upper parts of the fractions given. That is one thing we should always remember. So when you're told to add, you don't need to look at the numerator. Sorry, you don't need to look at the denominator. When you're adding fractions of similar denominators or when you're subtracting fractions of different, of similar denominators, sorry. But when it goes to different denominators, we are also going to look at it. We are going to see how does it come out, and we are going to look for the simple ways to work out such numbers. Because we believe there are so many ways to kill a rat. Isn't it, Esther? Esther, can you hear me?
Yes, yeah, I'm sorry. Yes,
Okay.
sorry.
All right. Gabriela, can you hear me also?
Teacher? Teacher Lynnder?
Yes, please.
I am not seeing the work you're talking about.
Okay.
Like
I'm going to repeat. Let me just. Let me just put off this one here because it's going to keep on with echo. So sorry for what has happened, because I was trying to put off one gadget. If there are two, they tend to disturb. Oh, some other person has joined us. Trust you're welcome. Can you say hi to us? Then we can take you through what we've just discussed.
Hi, good morning.
Good morning. Thank you so much. I'm Teacher Lynnder. Just trying to do something in mathematics with others, and I hope we are going to be doing it together. We are looking at operation of fractions, and our interest today is addition of fractions. As we've suggested that we give fractions attention before, and maybe in other engagements, we shall be looking at different topics as well. Today, we are looking at addition of fractions, and our main interest is in different denominators. But before we look at it, we are going to just have a little revision about similar denominators so that we can see how they look like, to remind ourselves what we always do when we are dealing with them. As Peace, you've joined us, can you say hi to us?
Hi.
Well, you are welcome. I'm Teacher Lynnder, and there are some others with us. Some of your colleagues had already introduced themselves, but basically we are just trying to open our main interest of our engagement today. Are we looking at additional fractions like I've shared with your colleagues? We are looking at operational fractions, and our main interest today is addition of fractions with different denominators. When I talk about different denominators, I mean when you're having maybe a half plus a third, where the two denominators are different of each fraction, they're not similar. But before, I'm going to share my screen and we try to see what we mean by similar and different denominators. Okay, let me hope every one of us can see my screen. Esther, can you see my screen?
Yes.
Esther, can you see my screen?
Yes.
Good. Trust, can you see my screen?
Yes.
Please, can you see my screen?
Yes.
Gabriela, can you see my screen?
Yes.
Okay. So when we are looking at fractions, addition of fractions, that's our topic. But I want us to have just some little revision about similar denominators. Fractions with similar denominators. And I hope each one of us knows that a denominator of a fraction is the lower part of a fraction. Is it true that every one of us is aware of that? Peace, are you aware of it?
Yes.
Gabriela?
Yes.
Esther? Trust?
No.
Okay. So when they talk about similar denominators, fractions with similar denominators, this is what they simply, let me just pick a fraction here. Let me just pick fractions will work for us, okay. When they talk about similar denominators, this is what they basically mean. If you have 1 out of 5, that is a fifth, plus, because it's addition, plus plus 2 out of 5. This is when you're dealing with similar denominators. You find that the numerators may be different or the same, but they will always have the same bottom numbers. So when you find such numbers, you don't need even to think a lot. It's a matter of coming here, you tell them that this fraction here, because when you have them different denominators, that means similar denominators, I'm so sorry, similar denominators, it means that you remain with one denominator. So this will equal to you remain with one denominator, and then you remain with, you pick only one denominator from the fraction you have, yes? Because it is 5 and 5, that means we remain with 1. So you come here, you add in, you add the numerators, that is 1 plus 2, which will give you, when you add 1 plus 2, you'll get 1 plus 2, you get 3 out of the same denominator. That's what we need to note. That's what we need to note. That is when you're dealing with the similar denominators. Anyone with a question about similar denominators, addition of similar denominators? Okay, Tessie, do you have a question?
No, I get you.
Thank you, that's good. Trust, do you have a question? Trust, do you have a question?
No.
Let us try to speak a little bit louder so that we can hear each other. Gabriela, do you have a question?
No question. No.
Okay. Peace, do you have a question?
No.
All right. That is basically with similar denominators. That was just a little bit of revision about them. And in other cases, I hope we are all well conversant with when to reduce and when to ignore the answer. Is it true? And that one, I want us today to pick ideas so that in our next engagement, we can see, in case you have such an answer, what can you do to it? In case I come up with such an answer, do I need to tamper it or I leave it the way it is? We are going to see that in our other engagements. Today we are picking ideas about addition of similar and different denominators. So let us see the one of different denominators. Let us see the addition of fractions with different denominators. Hope we can we tell the meaning of different? Gabriela, can you tell the meaning of different?
Yes.
If they say different, can you tell?
It means things which are not similar.
Speak a little bit loud and share with us about it.
The word different means things which are not similar.
Wow. Thank you so much. It means things that are not similar. So this time around, when they're saying addition of fractions with different denominators, they mean you are working out, you're going to look at operation of these fractions when the denominators are different, meaning that the lower numbers or the bottom parts of these fractions are not similar to each other. Let us look at this example here. I don't want to use the one that is already worked out because to learn how to handle these fractions. We can have this. Okay, Trust, can you read that one for us?
A third plus a half.
Good, a third plus a half. There are two ways we can work out such a number. The first one is getting the LCM, or it can also be called it can be called the LCM, or we can term it as the LC, the LCD. Any idea about the LCM? Who can tell us what the LCM means?
The lowest common multiple.
Wow, that's good. What about the LCD?
The lowest common denominator.
No, not the low, it is the lowest common divisor. Because we get it by dividing, yes? We look for that number that can be got, that number that can be divided by both 3 and 2. So there are two things, the LCM or the LCD. So you choose which one is simpler for you. Gabriela, how can we get the LCM of 3 and 2? Because we are looking for the LCM of 3 and 2. How can we get the LCM of 3 and 2? Gabriela?
We divide 3 and 2 by the prime numbers in their order. We divide.
Yes. There are two ways we can also get the LCM. One is by listing the multiples of 2 and 3. Then we choose the lowest, because lowest means the smallest. It can be the smallest, it can be the least. We remove the smallest number from it, the lowest common number. Then we can also factorize 3 and 2, and then we get the LCM. We choose from the two. This can be part of our work, and I don't want to, after doing this, we are going to remove it, yes? One, we can say we are listing the multiples of 3. We can list the multiples of 3, and this is how we can get them. How can we get the multiples of 3? How do we get multiples of a number? Multiples of 3, these are the numbers we get by, the answers we get after multiplying 3 by consecutive counting numbers. Counting numbers start from 1. So if we are getting the multiples of 3, the first multiple will be got by multiplying 1 times 3. That will be the first multiple of 3. So, Esther, can you give us the answer? 3, good. Then we can also, the next multiple of 3 will be 2 times 3, giving us, what's the answer there, Trust? 6, good. So the next will be got by Peace. Can you tell us how we can get the other one?
By multiplying 3 by 3.
Good. 3 times 3, giving us answer?
9.
9, wonderful. So when you're listing those multiples, you come here and you give us the answers you got. So the first multiple of 3 is 3, comma, we have 6, comma, 9, comma, we can also get others, okay? So who can guess the next multiple of 3 after 9?
12.
12, wonderful. Another one, the next multiple of 3, sorry?
15.
15, good. You're very good. And so many others. So we'll remove this. We've learned how to get the multiples. Then the next, we are going to look for multiple of 2, yes? Multiples of 2. And to get multiples of 2, still we multiply 2 by consecutive counting numbers. So who can guess the first multiple of 2 and how to get it? Are there some hands up? Some hands up. Let me check here. Abraham joined us. Sorry, okay, yeah, Trust, his hand is up. We shall give you time to greet us, but not now. Okay, Gabriela, tell us. Your hand is up already. The first multiple of 2 is?
We get multiple of 2 by multiplying 2 by 1 times 2.
1 times 2, and the answer is?
2.
2. Thank you so much. The answer is 2. So what will be the next if the first is 2? And the easiest way, you just keep on adding 2 to the answer you've got, 4. Okay, another one?
6.
6, good. Another one?
8.
3.
8. Huh? So 8, then another one. How do we get it? 8 plus 2, what do we get?
10.
10.
10, good. Then can we get another one?
12.
12, wonderful. And so many others, because the multiples are always countless. There are very many. You cannot finish them. Because you find that you will have 2 times 1,000, 2 times 10,000. All those, the answers you get will be multiples of 2. So from there, we come and look for the common multiples. The common multiples. And the common multiples are always so many, yes? You come here and say, which multiple is in 3 and also in 2? I want hands up, I want hands up. Let me check here. I want to see hands up. Trust, his hand is already up. Trust, give us.
She's not.
Trust. Which number appears in 3 and also appears in 2?
6 and 12.
We have 6 and 12. So you don't end there because you don't know these lists are endless. So you tell us that they are still continuing. Then from there, we pick the smallest number from our list we've got. Yes?
Yes.
We pick the smallest number. Esther, tell us the smallest number now.
6.
6. Thank you so much. So 6 will be the LCM. And we don't put it in brackets, so that is 6. So after getting the LCM, we now come and after getting the LCM, we get the rule says fraction times sorry, it was because of the network. Let me share my screen again so that we can continue from where we have just stopped. Oh, Chirabo, Jeremiah, you're welcome. Thank you for joining. We shall give you a chance to speak to us. You can, yeah. Jemima, we shall give you a chance to speak to us as we keep on continuing. We're dealing with additional fractions with different denominators, and we are looking at the first method, how to do it, because we said that we believe that there are so many ways to kill a rat. So we chose to kill it this way, and this is the first method of finding fractions with different, adding fractions with different denominators. So when you get your LCM, you multiply each fraction by the LCM. You also multiply each fraction by the LCM. Now we have a third times 3. Then after getting all this, yes?
Yes.
All this, sorry, let me just remove this line here. So after doing all this, yes? All the answer you get, is always divided by the denominator, yes? So you get all that, and we divide it by the denominator. It is out of, okay? So this is out of the denominator, and this is how best we can write it. Wait, sorry. This is how best we can write it. This is how best we can write it. Let me paste it there. Out of our denominator, which is 6. So 6 becomes the denominator. Because it's the LCD, it replaces 3 and 2. Are we together, my friends?
Yes.
Okay. So now after doing this, you come and work out these brackets here. So we have a third times 6. What we do, we get 6. We look for how many times can 3 go into 6. Yes? So how many times can 3 go to 6? You can guess the answer.
Twice.
So there it goes in, 3 goes in 6 2 times, yes? Then how many times does 2 go into 6?
3 times.
3 times, good. So after getting that, now we shall come here and say, just wait a little bit. My slide is becoming smaller. So after doing that, come and say, 3, we've agreed that 6 divided by 3 is trust. Trust. 6 divided by 3, what do we get? Jemima, mute your microphone, please. Jemima, your background noise is not doing us well. Mute your microphone, please. Good. So when we divide, when we get 3 divided by 6, we get 2. 6 divided by 3, we get 2. So we say 1 times 2 plus, so we come here and say 6 divided by 2, we also get 3. So we say plus. Sorry, it is network. So after picking out that, we give denominator 6. Here we can work out 1 times 2.
Lesoni sawa meka.
Okay. 5 minutes again. In 5 minutes. So I beg you mute your microphone because it's not doing us well. So after taking out this, we say 1 times 2, we get a 2 plus 3 out of the denominator, which is 6. So we get it out of 6. So when you add, to get the final answer, you say 2 plus 3, you get 5 out of 6. That is the first way of working out such a number. Then we also have another method, and let us also see how it works. So for this one here, this is how it goes. This is method 2. So what we do for method 2, we apply cross multiplication. So sorry, for method 2, we apply cross multiplication. So what we do for this cross multiplication, this is how it goes. We are going to look at these arrows here. We multiply the numerator denominator times denominator. Then the next is numerator times numerator, and that's how it goes. Then the other one is numerator times denominator. This is how the arrows move. After getting that, just come and pick these numbers here. So after doing that, you come and say 1, you pick numerator times denominator. So you have 1 times 2, 1 times 2. You put them in brackets. Plus, open brackets still. You still come and pick this numerator times this denominator. So you'll have 1 times 3. The whole of this will be out of the whole of this will be out of the whole of this will be out of 3 times 2. As you see this red arrow here that shows as you see that red arrow, how it moves, it multiplies the denominator by the denominator. So after doing that, you come and work out the brackets. You have 1 times 2, which gives you a 2, plus 1 times 3, which gives you a 3, all out of 3 times 2, which gives you a 6. So from there, your answer will be 2 plus 3, you get a 5 out of, you retain the 6 out of 6. So that is the other way of handling such a number. So Esther, can you share with me? Esther, Esther?
Yes.
Esther, can you hear me?
Yes, I do.
Which of the two methods could you choose to use? The second one, the first
I
one?
think the second one.
Okay. Peace, which one could you choose? The first one, the second one?
The first one.
All right. Then Gabriela?
I choose the first one.
The first one, okay. Trust, which one could you choose?
The first one.
The first one, okay. So I'm going to share some work in our group, and we are going to apply according to the methods we've learned. We are going to apply those methods and work these numbers I'll be sharing with you before the day ends. Unless someone has a question, then we can move on. Anyone with a question about it?
No.
Okay. Esther, do you have a question?
No, I don't. No, please. You're good.
Excuse me, teacher.
Okay.
Excuse me, teacher.
Okay. If we all have any questions, I wish you a nice day and get ready to respond to the work, visit the site, try to respond to those activities as we organize for our other engagement. I wish you a beautiful day. Bye-bye.
Bye.
Bye-bye, so you can leave the meeting.
Bye.
Oh, Sarah, you had joined us and we have meeting has ended. We shall meet next time. Endeavor to visit the site and respond to some work there. Bye-bye. Have a beautiful day. So you can leave the meeting.
Excuse me, teacher.
Yes, you're excused.
Where should we get from the work?
The work will be in the WhatsApp group.
Okay.
Yeah,
Ma-
try to
this
visit it before the time ends.
This is
Yes.
Shurabajama.
Okay. You're welcome, Chirabo. I will
Yes.
put the work in the link, in the group, and make sure you do it.
Yes.
Yes,
Thank
bye-bye.
you. Excuse me, teacher.
Yes, please.
Shall we discuss the work? We do it, then we discuss, or we send.
We are going to do it. We are going to respond to it and we shall give the feedback when we have the next engagement on Monday.
Recording in progress.
Any other person with a concern? Any other person with a concern? Jeremiah, you can leave the group now. Sanyu, we had completed. You will join us next time a little bit earlier. But try to check in the group and follow that link. You will listen to the lesson. Yes.